Question 2, Part D. The diagram shows a complex plane with origin O. The points P and Q represent arbitrary non-zero complex numbers Z and W respectively. Thus, the length of PQ is mod Z minus W. Part 1. Copy the diagram into your writing booklet and use it to show that mod Z minus W is less than or equal to mod Z plus mod W. After copying the diagram into your writing booklet, consider triangle OPQ, where side QP or PQ is the longest side of this triangle. Now, OP is complex number Z and OQ is complex number W. QP, using vector techniques, is the difference between complex number Z and complex number W. In other words, Z minus W. So by the triangle inequality, the length of side QP must be less than or equal to the sum of side OP and OQ. So we can write it this way: mod QP is less than or equal to mod OP plus mod OQ. Hence, mod Z minus W is less than or equal to mod Z plus mod W. Part 2. Construct the point R representing mod Z plus W. What can be said about the quadrilateral OPRQ? On the diagram in Part 1, I've constructed interval QR, which is parallel to interval OP and also equal in length to interval OP. So we can say that QR is equal to OP, which equals Z. And I've also constructed interval PR, which is parallel to interval OQ and also equal in length to interval OQ. So we can say that PR equals OQ, which equals W, and I've marked these sides accordingly. So going through the solution, on the diagram in Part 1, QR equals OP, which equals the complex number Z, and QR is parallel to OP. Also, PR equals OQ, which equals the complex number W, and PR is parallel to OQ. Hence, OR is equal to Z plus W using vector techniques with length mod Z plus W. So going back to the diagram, using vector techniques, if we treat OQ as a vector and QR as a vector, then Z plus W is vector OR. Now, since QR equals OP and QR is parallel to OP, quadrilateral OPRQ is a parallelogram. Part 3. If mod Z minus W equals mod Z plus W, what can be said about the complex number W over Z? In Part 2, we deduced that quadrilateral OPRQ is a parallelogram. Now, if the diagonals Z plus W and Z minus W are equal in length, that means quadrilateral OPRQ is a rectangle. That also means that OP and OQ are perpendicular. So there's a 90-degree angle there. So going through the solution, we got mod Z minus W equals mod Z plus W, which implies the diagonals of OPRQ are equal. Hence, OPRQ is a rectangle. This means that OP is perpendicular to OQ. Hence, the complex number W can be expressed in terms of Z. W equals I times K times Z, where K is a constant. Rearranging this equation to isolate W over Z, we get W over Z is equal to I times K. Therefore, W over Z is a complex number that's a purely imaginary number with magnitude K.